Hello guys, welcome to the DMS online school. In today's video I'm going to revise a question coming from More Concept, which was sent to me by one of my students in my Telegram group. Alright, so let's read the question, which says in an experiment to prepare a salt, a learner reacted 3.0 grams of magnesium oxide with 40.0 cubic centimeters of dilute nitric acid of concentration 2.0 moles per cubic decimeter. So in this experiment, we are told that a pupil or a learner was going to prepare a salt, and this learner reacted 3.0 grams of magnesium oxide with 40.0 cubic centimeters of dilute nitric acid of concentration 2.0 moles per cubic decimeter. Then they are saying write a balanced chemical reaction or chemical equation for the reaction. Okay, so we need to write a balanced chemical reaction for the chemical equation for the reaction between magnesium and the nitric acid, dilute nitric acid. Okay, so I'm going to put the answers here. So we need to write a balanced reaction chemical equation for the reaction between magnesium oxide and the dilute nitric acid. So you know this magnesium oxide is a base. This nitric acid, it is an acid. When these two react, they'll form a salt and water. So the salt which they'll form should be magnesium nitrate. So it will be magnesium nitrate. Now whenever a salt and a base reacts, what is formed is whenever a base and an acid react, they form a salt and water, so it will be plus water. Now this is a weight equation, so we need to use this to write a balanced chemical equation. So magnesium in form of equation, it is written as capital M small letter G, which is magnesium. Then oxide is capital O like this, which is oxygen, then plus, then nitric acid, we just need to remember the formula for nitric acid, which is capital H, then capital N, then capital O, then there's a 3 here. Then when they react, these will put an arrow, they'll form magnesium nitrate. So magnesium, it is capital M like that. Then nitrate is capital NO3. Now this one has to be in brackets, and then we have to write a 2 here. Of course, if you don't understand this one comes from writing chemical formula. There's a video that I did on my channel, check through it, 172. So when this reacts, this is magnesium nitrate, then plus water. So water is just H2O. So now we need to balance. So balancing equations involves making sure that the number of atoms of each element on the left side of the arrow is equal to the number of atoms of the same element on the other side of the arrow. So start by checking. For instance, we will look for magnesium atom. Here we have 1, here we have 1, so these are balanced. Then we come to oxygen. Here we have 1, here we have 3. So what we are going to do here is this. Here magnesium 1, here 1, it is balanced. Here oxygen we have 1, here we have 3 oxygen atoms. When we add this 1 and this 3, we have 4. When we come on this side, we have oxygen 3 inside there, 3 atoms, but because there's a 2 outside here, if we say this 3 for oxygen times this 2, it will be 6. But again, we have this oxygen atom here, so this 6 plus this 1 oxygen atom, if we add them, it will be 7. So here we have seen that oxygen atoms are 4, here they are 7. So because of that, this equation is not balanced. So we have to make sure that this number of oxygen atoms balances. So to do that, we will go on the side with less number of atoms. So for instance here, if we decide to put a 2 here, we'll say now 2 times this 3 will have 6, then that 6 plus this one, it will be 7. That way we have balance. You see, so simple like that. Of course, for you to know balancing equations, you need to practice, okay? So it doesn't just come easy like that. So now we have balanced oxygen atoms. Let's shift to hydrogen. Hydrogen, it's this one here. Because of these 2 in front of it, it means that we have 2 atoms of hydrogen. Then we check on this side, we have hydrogen. Because of these 2 down here, we have also 2 atoms of hydrogen. So they have balanced 2 hydrogen atoms here, and here also 2 hydrogen atoms. We shift to nitrate. Nitrate, because of these 2 also here, we have 2 atoms of nitrate, or I mean nitrogen, not nitrate, nitrogen. Then here also nitrogen is inside, but outside of it there is a 2, so it means we have also 2 atoms of nitrogen. So it means that everything has balance. We have moved from this up to there. We have seen that this equation is balanced, so it is the one they were looking for. So it is balanced. So let's move to the other question here, which is B. Calculate the number of moles of Roman 1 magnesium oxide 2 nitric acid. So they need the number of moles of magnesium oxide. So for us to calculate number of moles of magnesium oxide, we need to know what we have been given. We have been given 3.0 grams of magnesium oxide. So let's go and see. So on B part 1, we are calculating what? Moles of magnesium oxide. Okay, so we are finding moles of magnesium oxide given that we have mass of magnesium oxide, which we are given, which is 3.0 grams. So given this, we can use this to find the moles of magnesium using this formula, which you don't need to forget. The formula is N, which is number of moles, is equal to mass given over molar mass of magnesium oxide. So this is the mass, which is this one. This one is the molar mass of magnesium oxide, which I'm going to show you how to find it. So molar mass of magnesium oxide is found from the relative formula mass of magnesium oxide. So you know magnesium oxide is capital M, small letter G, and capital O. On the periodic table, the relative atomic mass of magnesium atom is 24 here, and that of oxygen is 16. So what we can do here is just to sum these up. When we total them up, the value that we'll find, it will be the molar mass of magnesium. So say equals, so say like 24 plus 16. What are we getting? Something like 40, right? Because if we say 6 plus 4, it will be 0, remainder 1. 2 plus 1, it will be 3, plus that 1, it will be 40. So it will be 40 grams per mole. That becomes the relative, I mean the molar mass of magnesium. Now that we know the molar mass of magnesium, this one, and we know the mass, we can substitute this into this equation here, where we'll say equals, so where there is mass, we'll fit in 3.0 grams over, where there is molar mass, we'll put 40 grams per mole, so that this gram and this gram can cancel. Then we will say equals, so let's divide 3.0 divided by 40. So let me just get my calculator here. I have something like a calculator here. Let me just expand it. Yeah, so let me just do this. We have 3 divided by 40. What are we getting? 0.075. So here we have 0.075, which will be the number of moles. So you put mol as the units for mole. So then we are going to conclude to say, let me push it here. I'm going to say, therefore, number of moles of magnesium oxide is 0.075 mole. Okay, failure to put that value, you can get this one wrong. If you don't put the unit, you get it wrong. So on part 2, we are supposed to find the moles of dilute nitric acid. Calculate the number of moles of part 2 here, dilute nitric acid. So let's go for number of moles of dilute nitric acid here. So here we are going to say number of moles of nitric acid. So moles of nitric acid, which is HNO3. Okay, so what have we been given already for nitric acid? Let's check. We were told that in an experiment to prepare a salt, Elena reacted 3.0 grams of magnesium oxide with 40.0 cubic centimeters of dilute nitric acid of concentration 2.0 mole per cubic decimeter. So these are the values we are given for magnesium. We have volume of 40.0 cubic centimeters and also concentration of 2.0 mole per cubic decimeter. So these are the values already provided. So we are going to say that here we have volume of nitric acid, which is 40.0 cubic centimeters, and then concentration is 2.0 moles per cubic decimeter. So having these values, now the question is we find the number of moles. So it's like we are saying we don't know the number of moles. So we can look at how these quantities relate to each other. They have a formula which relates the three of them together. So this formula is this one here, which is concentration C is equal to any number of moles over V volume. Now the question wants us to find any, which stands for number of moles. So make it the subject of the formula. So it will be any is equal to concentration times volume. So that is what we are going to do. So put concentration C here, volume V here, then we'll multiply. Now, before you do that, this volume must be changed to cubic decimeter. Here we have cubic decimeter in the concentration, also this one, change it to that. So how do we change? If we have volume given to as 40.0 cubic centimeters, to change it to decimeter, you just divide by 1000. So you divide by 1000. When we do that, so we will do like this. So we'll divide 40, okay, by 1000 like that, so that we get 0.04. So it will be 0.04 as now the volume in cubic decimeters. So it is this volume we are going to use, not this one, okay, because that is how the volume is supposed to be. The volume is supposed to be in decimeter, cubic decimeter, in line with what we are provided here in the units for concentration. So once you convert this one to that, you now go ahead with the substitution. So here we'll just now substitute. We'll say equals concentration C is equal to 2.0 moles per cubic decimeter. Then we'll put the times here. Then the volume, it is this one here, 0.04. Then we'll put decimeter cubed. So you see that this one and this one cancels, then you remain with that one. So it will be equals, so 2.0 times that. So it means this one we have, it is this one times 2. So we'll just say times 2 equals 0.08. So it will be 0.08 moles. So now what we are going to do now, we'll say therefore, let me come here. We'll say therefore the number of moles of nitric acid is 0.08 moles, like that. That will be the answer there. Then now we move on and look at the other question provided here, which is question C. Question C says determine the limiting reagent. So we need to determine the limiting reagent between these two, which are reacting magnesium and the nitric acid. So we are determining the limiting reagent. So for you to answer this question, you need to know what a limiting reagent is. So on C, we are determining limiting reagent. So let me just define what a limiting reagent is. So we are saying a limiting reagent is a reactant. It is a reactant which is used up first in a chemical reaction. So like the way we saw that magnesium oxide is reacting with nitric acid to form magnesium nitrate and water. So these two, magnesium and the nitrate, nitric acid, are a reagent or a reactant. So as they are reacting, the one that finishes up first is known as limiting reagent, but the one which remains is known as the excess reagent. But this question is asking us to find the limiting reagent between the two of them. Which one got used up first in this reaction when they were reacting to form this and that? So for us to be able to do that, we need to balance this equation. Of course, we balanced it like this. So now, since these were balanced like this, what does these numbers entails or mean? These two, and here in front there's a 1. If there's no number, there's a 1. It entails that when you have 1 mole of magnesium, it always needs 2 moles of nitric acid. So whenever these two are reacting, this is the ratio in which they react. You can have 1 mole of magnesium, it will require 2 moles of nitric acid for the reaction to go out completely, for the two of them to react equally, so that none of them is an excess or a limiting reagent. Both two reactants finish up or finished completely to form this. Okay, that's what happens in this chemical reaction. That's what we call it a balanced chemical reaction. Now, in a scenario where we were given, we calculated the number of moles here previously. So let me just remind you, but avoid forgetting things. If you forget in science, you never pass it. So we found the number of moles of magnesium, and also we found number of moles of nitric acid here. Now these are very important ones because they are the ones we are going to use. It means that in this chemical reaction we were provided with 0.05 0.75 moles of this magnesium oxide, and also here we were provided with 0.08 moles of nitric acid. So this is what we were provided. So these are the moles. Here we calculated that the moles provided for magnesium are these, for nitric acid are these. Okay, now between this one and this one, which ones were less? So the ones which were less will become the limiting. Of course, considering that if you have 1 mole, you require 2, but if you have 0.75 of magnesium, then you need to double it to know what will be required for this. So when you look at this 0.75 8 moles. Is it a result of doubling this for you to get this? Because if you have 1, you need to double it to get 2. That's how it reacts. But if you have 0.075, if you double it, does it give you this? If it gives you more than this, then this one will be a limiting reagent. What you have been given is what is not, it's not enough to consume all this. So if you double this, for instance, I'm just pumping something in you so that you get the logic of how these things work. Because I know, I'm explaining this part because I know most pupils find this part very challenging, limiting and excess, knowing how this one works. Okay, it is very challenging to them. That's why I am explaining this. In a balanced chemical equation, it tells us that everything reacts equally. If you have 1 mole of magnesium, you need to have 2 moles of nitric acid. In a balanced chemical equation, that's how it goes. But you were provided now with 0.075 moles. So these 0.075 moles of magnesium need to be doubled for them to give an equal amount of nitric acid. So like if you have 0.075, if you double it, you multiply it by 2, it is giving us 0.15. So here we are supposed to have 0.15. So when you are given this, what you need also to, in terms of nitric acid, so that the two consume each other completely, is 0.15. But you are given this. So when you compare this and this is less. So what you are given is not even equal to what you need when you are using this. So it means what you are provided is less, and this is when this and this react, this will finish faster because this goes with this one here, not that one. It goes with this one. This one is less. Therefore, nitric acid is a limiting reagent already by logic here. But this is how we do it when we are calculating. We always test. So these are given moles. So you say, okay, if I'm given, you do like this. If I'm given 0, you do it like this. If I'm given 1 mole of magnesium oxide always will require 2 moles of nitric acid. That's how it goes in a chemical equation. That's how they react. But then you say, if I'm given 0.075 moles of magnesium, then you assume to say how much will be needed here. You put an X there. You don't include this value here. You put an X, then you cross multiply where you say 1 times X, you get X. Then you say equals, then 0.075 times 2, it will give you 0.15 moles. So this shows that these are the moles that are needed to react. So these are the moles of nitric acid that are needed to react with this. If you have this, it will require this to react. Now, you were given this. So the logic is, if the moles you are given are less than the moles that will be needed by the reaction or in a reaction, then the reactant of that moles is a limiting reagent. So here now you say, I'm going to put it in this way. I'm going to say, if the number of moles of a reactant given is less than the number of moles of the reactant needed to react in a chemical reaction, then the reactant is the limiting reagent. So that's how it is. So if the number of moles of a reactant given is less than the number of moles of the reactant needed to react in a chemical reaction, then the reactant is the limiting reagent. So in this case, we are referring to this. We have discovered that if you are using this of magnesium, it will require this of nitric acid for the reaction to go to completion, for both quantities to be consumed equally. But then in reality, what was provided is this. So what was provided and what is needed, they are different. What was provided is less, what is needed is more. So meaning since what was provided is less, so this reactant quantity is less, and the reactant, this one nitric acid, is limiting reagent. So that is that. So you do like this one, 0.08 moles is less than what? 0.15 moles. So say therefore nitric acid is the limiting reagent. Yeah. So for more lessons, online lessons, you can contact me on 0977 92 41 75 so that you can understand these things in detail. For now, guys, bye and see you in the next lesson. Peace.